Have continuation of the sequence part. Okay, in the previous class we have discussed about basic definitions. Along with that, let us have two definitions. What is meant by non-convergent sequence? Convergent sequence means what? If it tends to a finite quantity, it is said to be a convergent sequence. Non-convergent means it is not a convergent, so it not tends to a finite quantity. Either it may be divergent sequence. If it tends to an infinity, it is divergent, or it may be oscillatory, not a convergent, not a divergent, it may be oscillatory. Okay, so what is meant by non-convergent sequence? A sequence which is not convergent and it may be divergent or it may be oscillatory. Oscillatory means it is neither convergent nor divergent. Okay, next an important definition, that is null sequence. See here, it's very important. If you write null sequence as empty bracket, so it is wrong. Okay, null sequence means a sequence Xn is said to be a null sequence if it tends to 0 or if it converges to 0. It tends to 0. That is limit of Xn as n tends to infinity equals to 0. One example we may consider, that is limit of Xn as n tends to infinity. Xn here we are considering as 1 by n. As n tends to infinity means it becomes 1 by infinity. 1 by infinity means 0. If a sequence tends to 0, so it is said to be a null sequence. Okay. Next, limit inferior and limit superior. So these two are examples. Limit inferior, that is lower limit. Limit superior, that is upper limit. Okay, so limit inferior, a sequence is said to be inferior if it is a lower limit or least limit point is said to be limit inferior. That is represented like this. That is limit inferior of the sequence n as n tends to infinity, or it is as it is a least one, so we have to mark it as a limit bar n tends to infinity, that sequence an. That is limit superior, that is greatest limit point or upper limit point is said to be limit superior, that is represented as limit sup, that is an, sequence n as n tends to infinity. So that limit superior can be represented like this. This is a limit superior and this is a limit inferior, that is lower limit point and this is a upper limit point. Just consider one example, that sequence n equals to minus 1 raised to n. For every n belongs to natural number, if you go on substituting that n value from 1 to n number, it becomes either plus 1 or minus 1. If it is 1, so it is minus 1. If it is 2, it becomes plus 1. So go on like this. The limit points are minus 1 and plus 1. So here this is lower limit point and this is a upper limit point. That is limit inferior can be represented as minus 1 and limit superior can be represented as a plus 1. Okay. Next, one small theorem. So that is statement. In 2 marks such theorems are asked. Okay. If a sequence Xn is convergent, given a sequence is convergent for every epsilon is greater than 0, you have to show that modulus of Xn minus Xm is less than epsilon. So here you have to show that this is given, that is sequence Xn is convergent. You have to show this. What they have given, consider that. Let Xn be a sequence given that it is convergent. Let it be converges to L. Convergent sequence means it tends to a finite quantity, so we are considering as L. Given Xn be a sequence converges to L. If it is a convergent sequence according to limit definition, and also given that f1 is greater than 0, there exists a positive integer m such that, so this is the definition according to limit form. So that is modulus of Xn minus L is less than, there we are considering as epsilon, that is f1 by 2. Okay. Two functions we are considering, that is n and n, so we are considering as f1 by 2 for every n is greater than or equals to n. Okay, n and n, two functions are there. For that purpose, Xn minus L is less than f1 by 2 and Xn minus L is less than f1 by 2 for every n is greater than or equals to m. So we have to consider that Xn minus Xn. So part we are considering as xn minus xm. So that itself equals to this one, that is xn. I am writing as it is minus of xm. This is minus of xm plus L and minus L. By cancelling these two, plus L and minus L, again we will have that same form. Okay, there is no alter in these two, both are same. LHS equals to RHS, plus L and minus L, just adding and subtracting. So that is xn minus L minus of xm minus minus, again it is plus only, both are same. Okay, just by putting bracket, so we are making separate in these two terms, xn minus L and xm minus L. See here, whenever if you put less than or equals to sign, already you are learned in limit theorems, addition, subtraction, multiplication and division. If you separate the limit for, that is less than or equals to, the bracket should be separate, that is modulus of xn minus L plus modulus of xn minus L. Here we are making separate, modulus should be separate by putting the sign less than or equals to. Even though it is minus sign, here modulus is there, so it is plus sign. Xn minus L, that is xn minus L is epsilon by 2, and xn minus L, one is xn and another is xm, so it is epsilon by 2 plus epsilon by 2. By taking LCM to epsilon by 2, 2 will cancel, so it is epsilon. Therefore xn minus xm is less than epsilon for every n is greater than or equals to m. So this we have to prove that by considering limit definition, by considering xn as a sequence that must converge to L. So here, if xn is convergent, you have to show this part, that is xn minus xn is less than epsilon. Okay.